Hey everyone, in this video I'm going to be talking about how we can make a quadratic model for a situation with area and a fixed perimeter. So in this example, Noah wants to build a garden with a perimeter of 32 feet. Let x represent the width in feet and y represent the area feet squared. Fill in the table with the missing possible lengths and area of each possible garden, then write an equation to model the area y based on the width x. So the most important piece of information we have here is that he wants to build a garden with a perimeter of 32 feet. So that means that our fixed perimeter is 32. So fixed means that the perimeter of every single option needs to be 32. So remember, perimeter is what we get when we add up all of the lengths and widths. So if I have a rectangle, I get my perimeter by adding up both widths and both lengths, okay? So if I need to make a table with width and length, I know that one width, let me make that smaller, one width plus one length is always half of my perimeter, okay? So one width and one length is always half my perimeter. So that means my width and length in my table should add up to half the perimeter. Half of the perimeter. And in this case, the perimeter is 32, and half of 32 is 16. So my width plus length always needs to add up to 16. That also means that, so one way I could do this is in my table, if my width is 1, then my length needs to be 15 in order for this to add up to 16. 1 plus 15 gives me 16. But another way I can find it to be sure is I can always take 16, minus 1 to give me my width. Let me put that in a better spot. 16 minus 1 gives me 15. So that's my trick. I can either think what number plus 1 gives me 16 and realize it's 15, or I can think take half the perimeter and subtract the width to always give me my length. So for the next one, I would do 16, that's half my perimeter, minus 2 to give me a length of 14. All right, my next one would be 16 minus 3 to give me my length of 13. 13 plus 3 gives me 16, so this is working. 16 minus 4 gives me a length of 12. 16 minus 5 gives me a length of 11, and 16 minus 6 gives me my length of 10. Now to get to my area, I'm going to multiply my width times my length. So area is always width times length times length. Let me move that. Okay, so, oops. Oh my gosh. Okay, so for my first one, that's 1 times 15. So my area is 15. My next one is 2 times 14. So my area is 28. You can always use a calculator. 3 times 13. So that's going to be 39. 4 times 12 gives me 48. 5 times 11, that gives me 55. 6 times 10, that gives me 60. Okay, so now I have all my lengths and all my areas. There are more possibilities, but our table just only goes up to a width of 6. So now we're going to write an equation to help us to kind of describe what we just did using y and x. So my equation needs to tell me the area. So it's going to be y equals, because we're saying the area equals, I'll kind of translate it down here. And what did we do each time to find the area? Well, we did the length times the width. So area is length times width. But I need to put that, actually I'll put width first because that's how I wrote it before. Width times length. But I need to write this using x. Well, width is x. So instead of writing width, I'll put my x as my first thing I'm multiplying, times. Now the length is, we don't really have a variable for length, so we need to talk about the length in terms of the width. Well, how did we find, let's remember back to how did we find our length each time? Well, each time we took 16 and subtracted the width. Well, 16 minus the width every time, which is x, is 16 minus x. So that means our length is 16 minus x. You can remember this is always half the perimeter minus x. X times half the perimeter minus x is always going to give us our equation model for this situation, this type of a situation. Now we can go ahead and graph our equation in Desmos. And then using that graph, we're going to find the length and width of the largest possible garden with a perimeter of 32 feet. So I'm going to go over to Desmos and type in y equals x times 16 minus x. Oops, I forgot the 6. 16 minus x, parentheses. Okay, I'm going to need to zoom out. So I want to find the largest possible area. That's going to be the very top of my graph. And I just need to look at the point it gives me. So remember, x is the width. So it's telling me the width of the largest garden is 8, and the area is our y. So the area of that garden will be 64. So we know the width and the area of the largest garden, but we are going to have to figure out the length. So let's go right down real quick before we forget. The point was 864. So that means the largest possible garden with a perimeter of 32 feet would have an area of 64 feet squared. So remember, the 64 comes from the y value of 64. That's our area. And then the width is 8 feet. Remember, because x is our width. Different color. And then, actually, let's do yellow. And then our length, well, remember, our length and width always have to add up to 16 in this case. So the length is also 6 feet. Or, yeah, so and the length is 8 feet. It asked for the length and width of the largest possible garden. So we get the 8 from the graph, but then we find the length because we know 8 plus the length needs to add to 16. So 8 plus 8. All right, and then just a quick reminder, we talked about how we know this is quadratic. Some of you might be like, why is this quadratic? Well, even though we don't see an x squared in the equation, we have 2 x's being multiplied in our equation. Like there's an x outside the parentheses and an x inside, so x times x would give us an x squared. So if we were to multiply this out, it would give us an equation with x squared in it. So that's how you can remember this is quadratic. All right, hopefully this helps if you're doing the optional practice / it helps you prepare for the quiz.